Afternoon, everybody. Thank you for joining us on today's Adding Value programme. We've got a really busy schedule ahead of us this afternoon. So we've got some great presenters from across the automation industry. We're really lucky to be so well attended, and we're really lucky with some of the people that we have actually presenting for us today. So we're going to hear about some new products, we're going to hear about some new software, some innovations in terms of technology. Each of the presentations is going to be kept to about 20 minutes long, and then we're going to have time after each presentation as well for some questions and answers. So anybody with any questions, please put them into the Q&A section, and then what we'll do is we'll pick them up at the end of each presentation as well. So all the questions will be answered, and we'll do that at the end of each presentation. So next up we have Alan Baird from Sprint Electric with some colleagues talking about a type of drive called a matrix.
Well, good afternoon, everybody. It's a pleasure to see you. Hopefully you can see Mark and myself here. So just by way of introduction, if PowerPoint doesn't let us down, the best laid plans. Bear with me a sec. Mark, would you like to just introduce yourself?
Yeah, I'm Mark Gardner. I'm the technical director here at Sprint Electric. Been here for the past 11 years. My career's been all spent in drive design of one type or another, both for drive manufacturers and for OEMs. And I'm here today to talk about this new technology we have called Generis.
Neil, do we have you online?
You do, absolutely. I'm Neil Drennan. Can you hear me?
Yeah.
Okay, perfect. Yeah, Neil Drennan. I've been with Sprint for 7 years, previously with Eurotherm SSD Parker, and I'm here to support Alan on the new Generis drive.
Great. Thanks, Neil. Thanks, Mark. So my name's Alan Baird. I'm head of sales for AC drives for Sprint Electric. Pretty new to the team. So joined in November last year. Came from Danfoss, where I was country manager for the UK and Ireland for 7 years. Stuart, great to see your presentation. Great to see you as well. Hope you're all doing great, and hopefully the audience will also find this presentation just as interesting. So I am having some technology problems here. Stuart won't be surprised. I used to phone him and he would help me out with that, but we'll give it a go and see how we get on. So hopefully you could see that slide as well. So there's a couple of platforms we're working across, but so just by way of intro for the company, people might not know Sprint Electric too well. We're historically a DC drives company, so I'm really proud to say that our founder is still well and truly with us, Edwin Prescott. I think he's joined. I think he's in attendance now. So great to have Edwin. And he's beside Neil. There you go. So Ed started the company nearly 40 years ago, actually, with DC drives. So Mark, Neil, Ed, all have got experience with SSD and some with Eurotherm. So real drives people with real drives experience. And the company then progressed into digital DC drives, the first one being over 20 years ago for Sprint Electric, and great, winning the Queen's Award for Export. Just got to touch on it because it wouldn't be right, although we're talking about emerging technologies, and Generis, what we're going to talk the rest of our slot for is about that technology in a very different topology. We do DC drives, so not an emerging technology, but still a very important one. And if anybody has any requirements for DC drives, single phase, three phase, right up to megawatt class, please let us know. Don't let me know, because I don't really know much about DC drives, but let Neil know or my other colleagues as well. So just moving back to present day, and I'll hand over to Mark. So 2017 is when the business decided to move, not just to continue with DC, but also to enhance and moving into AC, but not a conventional AC drive, probably as most of you know them.
Yes, so as Alan said, our heritage is all DC drives. So when we started out, decided we needed to be in on the AC technology. We started discussions with the University of Nottingham, and they're experts in the technology which underpins Generis. And we set up an Innovate UK project and a knowledge transfer partnership in 2017 and in 2018. And then we built our first proof of concept. So we demonstrated all the key operating principles. Then moved on from there into technical demonstrators. First, we built 37 kilowatt. We also built a 350 kilowatt demonstrator, which indicated we could make this technology work at both sort of ends of its viable spectrum of power use. Then started homing that down more towards a product with our first prototype rated at 22 kilowatts. Moving on through the commercialization phase, where we're adding all the other features that you require in a drive. So we may have got the underlying technology working, but we still needed all the other features and functions that a drive requires. So there's a lot of development during that time as well. And then where we are today is that we're about to send out units for field trials with customers, with production shortly afterwards.
So that's literally happening today, and some units going out tomorrow. So as well as, sorry Dan, although this is really super exciting, shipping our first commercial products is almost up there with it as well.
I don't mind being a close second. It's fine.
So Neil.
Yeah, so just to give you an overview of the technology, just a very, very quick overview. Obviously, this is a model of a traditional AC drive. So you're bringing in three-phase with lots of capacitors and diodes producing a DC link, and then using that DC link to produce a pulse width modulated output, which obviously that's how most AC drives work. And this is great for powering, but when you're braking the motor, that energy comes back into the drive. It puts voltage on the DC link, and it's actually quite difficult to control that. So usually there's a brake switch in there. As it gets to too high, it dumps that energy out to resistors, which is really quite wasteful. And this technology improves on that. It can improve with a traditional AC drive. So if we have a look at this next drawing, this is obviously as we would call an active front end drive. So this is in effect two drives back to back. So you've got, again, full bridge at both sides. So the drive now will generate back in. It produces voltage onto the DC link, and then the DC link is then used to produce three-phase back out onto the mains. The only issue with this, it's quite noisy. It produces quite a lot of harmonics. And also at the same time, it's needing quite a lot of filtering on that end, third and fifth harmonic filters, those sort of things. So what's new? Well, the Generis topology is very, very different. So if we look at the Generis drive, it has no DC link at all. It uses 9 bidirectional switches. It uses very, very high processing speeds to switch those switches. And as I mentioned, they're bidirectional. So every input connects to every output, so the motor can be driven. And it also, if the motor is being driven, that voltage comes back in and can come directly out onto the mains. But because obviously we don't have that DC link in there, we're in a unity power factor. And so it's very, very clean back out onto the mains. That's the technology. Oh, and obviously it is still an AC drive.
Still an AC drive. If people think something completely different, it's still an AC drive.
Obviously, from an advanced technology point of view, we've pointed some of these already, but obviously from that design, as we mentioned, there's no DC link. It's direct three-phase. The beauty of that circuit is there's no electrolytic capacitors. In fact, even on the control and power circuit, we've used solid state capacitors. So we try and remove all the electrolytic completely out of the product where we have. Obviously, that means improved power quality. As I mentioned, from a EMI point of view, we're looking at less than 5% harmonic distortion. It's really, really ultra low harmonics, unity power factor, and obviously from a performance point of view, it's full regen performance. So you've got that capability of both braking and accelerating. In fact, it will hold full current at 0 speed continuously, unlike a traditional AC drive. Very, very high dynamic operation, and it's also it's firing a switching frequency of 10 kilohertz. So, but actually, because of the way we fire it, it's electrically very quiet, but it's also incredibly audibly quiet as well. But apart from that, we've also got a flexible block diagram to program it. It can do distributed over control over Ethernet with no PLC, and it also has an integrated web browser, which we'll be showing you in a little while.
Yeah, so here we're just looking at the drive itself. So it's a very simple construction there. You can see there's 2 grey connectors there at the bottom corners. So one is for one's your 3-phase input, one's your 3-phase output. That is all you need to hook up other than your control connections. So you can see up the top you've got an HMI, and below that you've got your control connections and Ethernet and normal analog I/O. And the dimensions are as indicated, so that is a very compact unit for the power size and functionality. Just looking internally now, you can see on here on the left-hand side the power board, and if you count down on that left-hand side, you can see sort of 9 grey blocks, which are the connections to the gate drive for those 9 bidirectional switches that Neil mentioned. You've got fans there at the bottom, and then connections to the AC on the right-hand side. Just building up the product now, you've now introduced a gate drive board which has the functionality for STOs. Safe Torque Off is included on that gate drive board, which you see in the middle there. And then up at the top we have the control board. So this has got you can see an any bus connector. We've got a very powerful microprocessor and FPGA to do the power switching, and then on the right hand side you've got a dual channel encoder with programmable voltage supplies 5, 12 or 24. And then finally, as a product, this is a product running, you've now got the HMI there, which is removable, so that can be put on a cubicle door, and then all the control connections there with the wires on the right hand side. What we're looking at here is the product roadmap. So at the moment, with our resources, we're targeting the smallest power size in the range. So we plan on making 4 different sizes running up to 200 kilowatts. They will all use the same control platform. And as I mentioned earlier, we have confidence that this technology scales across the range. There's no fundamental limitation, either low down or high up in power. So provided the power devices are available, which they are, then we can easily cover that range. But we're focusing on the launch of the size 1 at the moment, but have plans to go up to size 4, possibly beyond and possibly below. Just depends on where the market eventually ends up. But there's also options to go to silicon carbide as well in the future. As I mentioned earlier, the converter only has 6 power connections, so you're going 3-phase in and then 3-phase out. We've not got any external filters, 5 filters or chokes or anything like that, which means you've got fewer cables. With AFE, there's typically around 14 connections, but we're just talking 6 power connections. Obviously, you still have your control connections, but just in terms of power, that's all there is. At the bottom, we've got a comparison there with ultra low harmonic drive modules. So the Generis there on the left-hand side in red, that's weighs 22 kilos. The nearest competitor in the green is about 32, so significantly heavier and larger. And then another competitive product, an active front end there at 52 kilos, so much bigger again. Here what we're representing is a typical cubicle there with the dimensions shown 800 by 2250 by 600, and then the Generis dimensions below that, the 264 by 576 by 280. And you can see that once you put that into a cubicle, or the opportunity really for reducing cubicle size, because you'll end up with a cubicle which is a third of the width, a quarter of the height, and half the depth. So this is a significantly smaller product than what is commonly available in the market today. If we look now what the benefits are of this AC to AC conversion technology, well, first of all, there's low supply harmonics. I think it's fair to say that that is useful in any application, but we recognise that particularly so in HVAC, oil and gas, and the water industry as well. There's also regeneration, so that the unit can continuously or transiently ship power in either direction through the converter. Very clear application in elevators and cranes where you've got a gravitational load, but also when you wanted to slow things down very quickly, like a centrifuge. Then, as we've said earlier about that it is just a drive, and it's a high performance drive, so we can use it in any process control or web handling where you need very precise control. So we also have those dual encoder inputs, so we can configure it for winding applications as well. The unique technology that is in Generis, where we have this AC to AC conversion with no DC link, it is very well suited to applications where you spend a long time at low speed. In a conventional inverter, what happens is a couple of the power devices just get hugely overloaded, and so you have to derate the converter. But in a matrix converter, this isn't a limitation, so you can sit at full torque, zero speed indefinitely, which is particularly good when it comes to deck machinery or any kind of thermal process where you have a low speed operation. And finally, in terms of power density and ease of installation, we talked about how few hookups there are in terms of power, but also control. So it's very simple to install. And I think any of these applications will benefit from that. Finally, just a brief mention about the digitisation. There's been discussion in this forum today about the possibilities for using the data that the drive generates, because it's controlling the motor. It has to measure current, has to measure speed, it's measuring temperature. All of this data it provides insight into the final process. And so what we're doing is we're capturing that data with an internal web server, which is also used for configuration of the product, which Neil will come on to. But that web server can then stream the data into the cloud, where you can throw analytical tools at it for condition-based monitoring or preventative maintenance, which is essentially another revenue generating opportunity for your business.
Okay, so obviously, as you saw on the control board, there was space there to plug in for conventional comms. So we're using the Anybus Compact Com plug-in module. It auto configures it, and obviously that means if you are connecting to your system using Profibus, Profinet, Modbus, this is just a handful of the possible options that we have, and that sits on the board. So you literally just need the Compact Com module to be able to do that. In addition to that, we also have, as Mark mentioned there, built into the drive, it has its own web server. So the software to program the drive physically sits inside the drive. Okay, so what we're going to try and do, we're going to try and do a live demo of the software in the drive. So let me just see. I'm just going to try and share my screen into the wild. So hopefully now you're all seeing the actual configuration software. Yeah, just give me an okay, Alan, because I can't see that. Yeah, is that okay?
Yeah, we can see that.
Yeah, perfect. Okay, so what this does, this is actually sitting inside the drive, so you don't need to buy any software or load any software in your PC to be able to program the drive. All you need is a web server. This particular thing is connected through the web directly to the drive. And as you can see, it's block function programming. So what we've got a range of digital inputs coming into the drive, which are all fully programmable, and a range of analog inputs into the drive. The beauty of this block technology is, unlike on a PLC where you need to know whether this is an integer or whatever, the analog and digital I/O are already pre-configured. So it's very, very easy to add blocks to the configuration. This is just a very typical application where you've just got analog input coming into your user demand. But obviously what we can do is add blocks very, very easily. So if you were to add an I/O block and you wanted to use one of the additional analog inputs, you can literally just bring this into circuit. Excuse me. And basically, once you've got that in there, you can use it as part of the process. We can literally just zoom in and out from where we've got. So that would be a second analog input that we might want to bring into the circuit. Maybe we just want to add these two together. So we would maybe just add a function block like a well, actually, we can use a mass function. This is probably the easiest one. Let me just add a mass number 2. There are 40 of these mass functions. These are really very, very useful functions. So if we look at the mass function, here's the block itself. We can open the block up here, and this mass function, that's in effect what you're looking at, and you can configure what that function is going to be. So if I actually look at the function itself, at the moment this is absolute A, but it could be A plus B plus C, A minus B times, there's a lot of functions. So let's just do A plus B plus C as an example. Just put that in there, put it in circuit, and as you can see, if you actually look at that mass function now, it's actually telling you that it's A plus B plus C, and it is literally this easy to connect up. So if I actually just want to bring that in circuit, let me just bring it down here. I can actually connect this analog input into analog input B, for example. And then if I wanted to, I can bring that analog output here. I can delete it from where it is at the moment and actually bring it in the other side. I'll just connect into analog input A. And then all I can do is take that out there and actually configure it back into the application set point. Obviously, that's just an A plus B plus C. I've got lots and lots of additional blocks that I can add in. I've got PID blocks. Oh, sorry, went into the wrong one there. So if I'm looking at function blocks, I've got 140 different function blocks, including PODs, changeover switches, binary decoders, timer functions. It's very, very quick to build up and configure your drive to match the application. Once that's done, you can literally just save it. You can save it to the file, or you can save it into the drive. That's it done. You come out the drive and it's all configured and ready to go. Okay, that was a quick demonstration of the block functioning.
Thanks. Okay, so zooming on, we've got another platform open as well. All right. So this is the worry. Let's see if this works. So this is actually, if you can see that, that's actually Generis drive. We're working a back-to-back motor rig there. So that's actually working in our factory here, and just some typical waveforms as well. Apologies, it's zoomed out a little bit, but that's the unit there. So you're actually running, if anybody's not seen one of these types of topologies before, working in the flesh. So let's just see if I can get this better version.
You're on the summary there.
Yeah, in the interest of time. So really just to summarise, and the title of the event that we're in now is Emerging Technologies, and hopefully you can see here we're a small company. You know, Sprint Electric, we're based in Arundel in West Sussex, south of London. If anybody's ever coming nearby or would like to come and see us, please reach out. But you know, we're relatively small. I think, to my knowledge, the last British-owned drives manufacturer in the UK. So, you know, we're very proud of the work that the team have achieved up until this point. I'm a newcomer, so I'm not taking any credit for it. But I think the guys and girls have done an absolutely fantastic job. And here you can see now, without repeating what the guys have already gone through there, I think we really do have an emerging technology. And one of the lines that's in the text there, we're talking about, it's a brand new, it's incrementing AC drive technology. We feel very much there's a strong place, and will be for a long time, for 6-pulse conventional AC drives, for AFEs, but also for this technology. This is quite new to the market. There's the topology itself, there's 1 or 2 other products. There's a brand new one just come on that's an integrated motor and drive from the US. Really, really interesting. And I'm delighted because they're also seeing that this is one of the ways forward for variable speed drives. So thanks very much for your time, everybody. Do appreciate it. Sorry about the mess up at the end there, but thanks a lot. And any questions?
I think we're following on the trend, Alan, of everybody being happy with what's covered in the presentations. Again, you know, as I said before, like after the other one, sorry, that, you know, there will be information shared with everybody. So if anyone has any questions they want to come back to us with afterwards, or if you're watching these videos back and you have questions, then send them through and we'll be able to follow that up.
Yeah, so, Daniel, if anybody wants to send anything or any questions to us, if they send it to sales@sprint-electric.com, that will get straight to us and we'll jump on it. Yeah.
Perfect. Thank you very much.